All right, and welcome to our last video. This will be for questions 23, hopefully through 34 on the study guide. And so we're going to use some Euler's formula. And remember that this relates to the number of faces, edges, and vertices in a shape. And we are supplying that formula, but we're asking you to apply that formula, meaning you need to know what F stands for, you need to know what V stands for, and you need to know what E stands for. Of course, F is faces, V is vertices, and E is edges. And so we can use his formula in order to solve for those missing pieces, whether we don't have a picture or whether we're just double checking our work or whether we see the front of a picture but we can't see the back. It is sometimes difficult to count faces, edges, and vertices, so this formula comes in handy. And so let's start with the formula that is supplied, and then let's apply it. F plus V equals E plus 2. So we're looking for our number of faces on this 23. So we're going to leave that as F. V we're going to fill in as 10. E is going to be 15, and that's going to be plus 2. What is 15 plus 2 on that side? I can simplify that to 17, and then I'm going to subtract 10 from both sides. And when I do that, 17 minus 10 is going to give me 7 faces. Okay, let's do that again on this next problem. F plus V equals E plus 2. Faces is 8, vertices is 6. We're trying to find our number of edges, so we'll leave that as E. What is 8 plus 6? Well, 8 plus 6 is 14, so that's equal to E plus 2. I'm going to subtract 2 from both sides, and of course I'm going to get 12 edges. 12 edges, okay? Now they give me a picture. And they say count the number of faces, vertices, and edges. We're also going to confirm that with the formula. So when I look at this shape, I have 2 bases. This is a prism. What kind of prism is it? It is a pentagonal prism. They get fancy. You can call it a pentagon prism if you want. Pentagonal because it's got a pentagon, 2 congruent pentagonal faces. And then what that means is that I also am going to have 5 walls. So all of these walls between. So those 5 walls plus the top and the bottom, ceiling and the floor, that is going to give me a total of how many faces? That is going to be 7 faces. Okay, now I'm going to count my number of vertices. Of course, the vertices are these pointy parts. So 1, 2, 3, 4, 5 at the top, 1, 2, 3, 4, 5 at the bottom. That's where 3 or more faces meet. That is going to give me a total, that's where 3 faces meet. And so that's going to give me a total of 10 vertices. And now let's count the edges. Of course, the edges are just going to be those surfaces where 2 of the flat surfaces meet. So 5, 1, 2, 3, 4, 5 in the middle on the walls, 1, 2, 3, 4, 5 at the bottom. 5 times 3 gives me 15. But let's make extra sure, let's be extra cautious, especially because this is a test, and let's plug it in and make sure we counted right and confirm with Euler. So F plus V, so that's going to be 7 plus 10, is that in fact equal to 15 plus 2? Sure is. 17 is equal to 17, and boom, I did it right. I know I counted right. I know I didn't miss anything. So that is Euler's formula. So make sure you know how to apply that because we will supply that. All right, remember we talked about cross sections. So a cross section, we talked about birthday cakes in my class. We talked about when you cut the cake, what 2D shape is left when you're looking at it. So if we were to cut this cone parallel to the base and you were to stamp this shape on somebody's hand, that 2D shape, what would that be? This is going to be a circle for this cone. What about if you cut this pyramid parallel to its base? Well, what is left? That is going to be a hexagon. It'll be a hexagon stamp, hexagon 2D shape. And then what if you cut this party hat, this cone, right down the middle through its vertex? That is going to give you a triangle. Okay, so those are cross sections, just describing what 2D shape is left when you put a plane or you cut a 3D shape. All right, and then I loved this last lesson. In my class, we talked about video games, and we talked about finding the different levels when you're given similar figures. So when you're given that 2 shapes are similar, that means that they are the same overall shape, but different sizes, and their dimensions are going to be proportional to each other. And so what we're going to do first is find our similarity ratio, surface area ratio, and volume ratio. So similarity ratio is going to be A over B. Surface area ratio is going to be A squared over B squared. Our volume ratio is going to be A cubed over B cubed. So in my class, we talked about like the different levels. You have level 1, level 2, and level 3. And so then we looked at these shapes, and we know, y'all, we're not giving any information about the dimensions of these shapes. So we talked about these kind of like the two players that pop up in a video. We know nothing about these two shapes except for that they are similar to each other. But we are provided with some stats about these two shapes. On the stat sheet, it says that the surface area of this shape is 150 meters squared. The surface area of this shape is 294 meters squared. So what level does that go with? That goes with the surface area ratio, which is level 2. So that's going to be my a squared over my b squared. So player 1, that had a surface area of 150. Player 2 had a surface area of 294. And the first thing we're going to do is reduce this. So 150 divided by, or 150 fraction button, 294. That is going to be as a fraction. That is going to reduce to 25 over 49. So that's what I put for my surface area ratio. 25 over 49 is going to be my a squared over my b squared ratio. So that one is a squared over b squared. So if that's a squared over b squared, how do you get back to a over b? You're going to do the square root of 25 over the square root of 49. Why? Because I'm going from something that is squared to something that is not squared. A squared to a, I have to take the square root. That is going to be 5 over 7. If that is 5 over 7, why does that allow me to unlock level 3? Well, because I need a and b, which I just found. 5 and 7 are a and b. So to find level 3, I go 5 cubed for volume and 7 cubed. So 5 cubed we know is 125. 7 cubed is, I think, 343. But y'all, let me type it in because I am tired. 7 to the third power. Yep, it's 343. Trust yourself, guys. But also, trust but verify. Type it in the calculator because you got one. Okay, so those are our values. There's our similarity ratio, our surface area ratio, and our volume ratio. All right, let's look at our next two players. I've got two I've got two pyramids with triangular walls with rectangular bases. So these are triangular pyramids, and it says that they're similar. We're given that they're similar. So we want to find its similarity ratio, which is a over b. Level 2 is its surface area ratio, a squared over b squared. And then level 3, its volume ratio, a cubed over b cubed. So we're given these two players. We know nothing about their dimensions, so we can't actually find the surface area or volume or similarity ratio because there are no dimensions listed. But we do have some information that's given about them, where we have a little stat sheet that says, hey, the volume of this one is 125 centimeters cubed, and the volume of this one is 216 centimeters cubed. So what level does that go with? That goes with the third level, volume ratio. So I've got my a cubed and my b cubed. So that's going to be 125 over 216. And I do not believe that that simplifies. We could type it in just to make sure. 125 over 216 cannot be reduced anymore as a fraction. So that is going to be my volume ratio. That's level 3. There's my volume ratio fully simplified. So if that's my a cubed over my b cubed, how do I get back to a over b? Well, what is the inverse of cubing something? It's going to be taking the cubed root. It's going to be the cubed root of 125 over the cubed root of 216. You could type that in your calculator. Cubed root of 125, we know it's 5. Cubed root of 216, I believe, is 6, but let's just double check. 216. Yep, 5 over 6. So there's level 1 unlocked. My similarity ratio is 5 over 6. So that works with the perimeter and the side lengths. Its similarity ratio is 5 over 6. And so how does that help me find my surface area ratio? Because now I have A, it's 5. Now I have B, it's 6. So to find my surface area ratio, I'm just going to square both of those. That's going to be 5 squared over 6 squared. 5 squared is 25. 6 squared is 36. So then all three of these are filled in just like they asked me to identify. Okay? And then we have a few more problems. These, we want to actually use those values. So we're going to find the exact same things we just did. Everything's the same up until we actually get to use those to see why do these relationships help me. So a over b, a squared over b squared, and then a cubed over b cubed. Okay. So it doesn't even actually say what kind of figures they are, given the surface area of these two similar figures. So we're given the surface area of both. Given the surface area, solve for the unknown volume. So in figure 1, I don't know what shape it is, but I'm given the surface area of this one and the surface area of this one. And so what level is that? That's going to be level 2, which is surface area to the second power. So both of those to the second power. So that's going to be a squared over b squared. So I'm going to fill in 17 over 1088. We can simplify that as a fraction, I believe. That is 1 over 64. So I'm going to fill that in for level 2 surface area ratio. 1 over 64 is my surface area ratio. If that is 1 over 64, how do we get our similarity ratio? Well, we take the square root of 1 and the square root of 64 because we're going from something that is squared to something that is not. So that's 1 over 8. How does that help me find my volume ratio? Because I'm just going to cube both of those things. 1 is A, so 1 cubed over 8 cubed. That's going to be 1 over, what is that, 250... Nope. 512. 64 times 8. Yep, 1 over 512. So there are my 3 ratios. But now we're going to take this one step further and we're going to actually solve for a missing piece. So it gives me my volume of the smaller figure and it wants me to find my volume of the bigger figure. So we're going to fill in a V there. I'm going to say V is volume. So I know the original volume of figure 1 is 23. I'm trying to find the original volume of figure 2, which we're going to call V. That should be equal to the volume ratio, which we have. We have the volume ratio. It's 1 over 512. So I get to fill that in right here, 1 over 512. And so what I'm going to do is I'm going to cross multiply. So that is going to be 1 times V is V, 512 times 23 is going to give me 11,776. What are my units? km cubed. So 11,776 kilometers cubed. That's my volume. So I was able to use this ratio in order to solve for missing volume. All right, exact same thing on the next problem. Again, we are given surface areas. So we're given the We're given the 27. We're given the 300. That is level 2. So I've got A over B. I've got A squared over B squared. And I've got A cubed over B cubed. And so that is level 2 behavior. That's level 2 information. That is going to be my A squared over my B squared. So that's going to be 27 over 300. So 27 over 300 simplifies as a fraction to 9 over 100. So I get to fill that in right here. 9 over 100. That is 9 over 100. There we go. So how do I go from there, which is the second level, up to the similarity ratio? I'm going to take the square root. Square root of 9 over square root of 100. So the square root of 9 is 3. So the square root of 100 is 10. So there's my A and there's my B. Well, then that helps me find my volume ratio because I can just cube those. 3 cubed over 10 cubed. 3 cubed, I believe, is 27. 10 cubed is 1,000. So 27 over 1,000 is my volume ratio. So now we're going to use that to actually find my unknown volume. And so I am given the volume of the smaller shape. We want to find the volume of the bigger shape, so I'm going to put a V there. And so that's going to be 189 over V. The actual volume should be equal to the volume ratio, which we have right here, 27 over 1,000. So I'm going to set that equal to 27 over 1,000. And then I'm going to cross multiply. So when I cross multiply, that is going to be 27 times V equals 189,000. So 189,000 divided by 27 on both sides. That is going to give me 7,000. What are my units? My units are in meters cubed. Meters cubed of the larger shape. All right, friends, so that was given the surface area, finding the volume. Now we're going to be given the volume, and we're going to be asked to find the surface area. So we're given the volume on this. We're given the volume on this one. Same thing here. Figure 1, player 1 has a volume given, and we're going to use that in order to find my ratios first. So again, same thing at the beginning, A over B, A squared over B squared, A cubed over B cubed. Okay, so I've got, that is A cubed over B cubed information because it's volume. That is 8 over 27, which is fully reduced. So I get to put that right here. Okay, so if that's my A cubed over B cubed, how do we use that to go back to A over B? Well, to go from something that is cubed to something that is not, we're going to take the cubed root. So cubed root of 8 over the cubed root of 27. Cubed root of 8 is 2. Cubed root of 27 is 3. So that is going to be 2/3. So 2/3 is my similarity ratio. There's A, there's B. How do I use that to find my surface area ratio? Well, I'm just going to take 2 and square it. I'm going to take 3 and square it because we want to square both of those. So what is my surface area ratio going to be? 4 over 9. And then it gives me the surface area of the smaller shape, and it wants to find the surface area of the larger shape. So I'm going to put an X there. So 36 is the original surface area of the figure 1. That's what was in the description. We're trying to find the surface area of the larger shape. So what do I set that equal to? I'm going to set that equal to the surface area ratio, which is 4 over 9. So I'm going to set that equal to 4 over 9, and then I'm going to cross multiply. And so when I cross multiply, I'm going to get 4x equals 9 times 36, which is 324, and then I'm going to divide by 4 on both sides. When I divide by 4, I'm going to get 81. What are my units? Inches squared, because this is surface area. All right. Last one, y'all. You've made it. All right, so volume. We're given volume on both of those. So we know that volume is a cubed over b cubed. Information. Here's a over b. Here's a squared over b squared for surface area ratio. So we are given a cubed over b cubed information. So what do they actually give us? They give us 125 over 216. That cannot be simplified as a fraction, so we leave that how it is. That's fully simplified. There's the volume ratio. How do we use that to go to the similarity ratio? To go from something that is cubed to something that is not, we take the cubed roots. The cubed root of 125 for a is 5, over the cubed root of 216 is 6. I feel like we just did this. Let's just keep going. Okay, so that's 5 over 6. Okay, so let's unlock level 2. I'm going to take a, which is 5, and square it. B, which is 6, and square it. So that's going to be 25 over 36. So I've got my 3 ratios filled in, and now I'm just going to choose which ratio do I need in order to find a surface area. Well, the surface area of the smaller one is given. We want to find the surface area of the bigger one, so we're going to put an X there. You could use any variable you want, but my 5's and S's look a lot alike, so I'm just going to do an X. So the surface area of 200 of the original over the original bigger surface area should be equal to the surface area ratio. Well, which one is that? That is going to be this one. So we're going to set that equal to 25 over 36. Again, we're just going to cross multiply. So when I do that, that's going to be 25x equals 36 times 200, which I believe is 7,200, but I just want to make sure. And so when I cross multiply that and I divide by 25, I'm going to get a surface area of 288. So what do I fill in for my units? That is going to be in inches squared. So we just had to decide which of these 3 ratios did I need. Because I was working with surface area, that's level 2, which is 25 over 36. Set it equal to 200 over x and cross multiply. I hope that you are having a fabulous evening and you are going to rock this test.